Welcome to ICE Education, the only education that matters. Okay, Andile, this is what we have as problem. So, what do? They said a machine is engaged on a repetitive work, each cycle of operations occupying one cycle of its shaft. The driving torque required on the machine shaft is 40 Newton meter during its end rate of its rotation. 25 Newton meter during the next 20 and 5 Newton meter for the remainder of the revolution. The rotating part on the machine shaft have moment of inertia of 3. Now they said the machine is driven through power gearing by an electrical motor whose speed is 4 times than the one of the machine. The rotating part of the motor shaft have moment of inertia of I to be 0.81. Assuming that the motor power developed a constant torque, find its magnitude. Okay, first of all, as you can notice here, Andile, we've got two elements, right? Which is the machine and the engine. Now, here they say the driving torque required on the machine shaft is 40 Newton. So all this information provided here is for the machine shaft, or to plot it here. Let's start by plotting first. We see what we are talking about. Kick at it. Let's use the technology. I'm getting better with this one. I like it. Okay, so we do agree here we've got torque in Newton meter and we've got theta. We know that we have to put them in what? In red. So here's the thing. They say the driving torque required on the machine shaft is 40 Newton meter. Let's say we are here. I draw 40. Do you see it? I'm gonna do it with the ruler. They said it is 40 Newton meter during 100. So let's say 100 is somewhere here. Wait, what did I do? Let's say 100 is somewhere here. You see, the kids where you stay, they're always having good time, eh? That's nice. Okay, what's happening here? Well, remember, all this angle here will convert them after. For now, let's plot first. They always have good time and I love it. So it is 40 during 100. How did I zoom out? And then they said it is 25. Do you agree that 25 is somewhere here?
Yeah.
It's below 40. So it means that you have to drop this thing here. And I think I'm going here and do like this. Let me try to make this make sense. Okay, let's make it like that. Do you agree that here we are here at 25, Andile? They said at 25 during the next 120. What is the next 120, Andile?
It's
220. No? So we're gonna move 25 constant until 220. So let's say we draw this line here. It's somewhere here. Let me just draw first. Now, after 25, what are they saying? They say it is 5, so it's dropping somewhere here at 5. So we are here. We drop at 5. And then they said it is at 5 for the remainder of the revolution. The remainder of the revolution is what, Andile?
360.
360. So this is how the graph will look. I'm just trying to draw like this for beauty. Now, any question on how we plot this thing, Andile?
No question.
Now, personally, I think that they were supposed to say, this is how we draw it. It is 40, and then they say it drops at 25, and then remain constant after the next 120. But this is basically how it is represented. Are we together, Andile?
Yes.
So what are we looking for? We are looking for the torque of the motor. Remember, what we do have here, Andile, is the graph, the path effectuated by the machine. I don't know if you see. So what does it mean? For you to get the power, remember, these two, they are meshing through gearing. Machine, because they say the machine is driven through gearing. Because they have that, so you have the relation saying that power of the machine I will call it MA, and the motor I will call it MO. Is it fine?
Yeah.
So both powers, they are the same. Now, what do we do? What is power of the machine? Power of the machine is equal to mean torque multiplied by W of the machine. But power of the motor is equal to torque of the motor multiplied by W of the motor. Now, the question that I want you to ask me is, why is it like, when is it on the motor we are not using the mean torque? The simple reason is we use the mean torque on the one that we have informations on how to plot. Because remember, what is the mean torque? Mean torque is work done over what? Theta. And we can only get it for, in this case here, for the machine, because we have all the information to plot here of the machine. So if we have to recall, we have to do what we know from the beginning. You can come here and say work done of these graphs here. Remember, this is for the machine. Do you understand?
Yes.
So what is the work done here? You can split this in 3 shapes. You can split them in 3 rectangles. It's up to you. You can split them like this or like this. It depends on how you want to do it.
Okay.
I don't know if you see. You can also split it like this. You can say this one is rectangular 1, this one is rectangular 2, this one rectangular 3. You'd get the same thing. But let's keep the consistency. Let's take this one 1, this one 2, and this one 3. Remember, all the angles should be in radian. How do we convert in radian again?
Pi over 180.
Pi over 180. So, what is 100 times pi over 180?
Five over 9 pi.
5 over 9 pi. What is the next one? 220?
2 over 9 pi.
1 over 2? This is 1
1.
over...
It's 2 over 9 pi.
2 over 9 pi.
It's like, that's a mixed fraction. Yeah.
It's 220 multiplied by pi divided by 180. What is it giving?
It's 1.
1?
And then 2 over 9 pi.
2 over 9 pi, like this. Or like this, ne? And 360 is 2 pi. Are we together?
Yeah.
So for the first rectangular, if we can consider it like this, what is the formula of the rectangular? It is based on height, right?
Yeah.
So what do we get? We have 5 over 9 pi. What is the height?
40.
40. For the second rectangular, what do we have? We have the change. So you have 9 over pi, 5 over 9 pi, half. So basically you have 120. 120 gives us 3 pi over 2, is it? Check.
2 over 3 pi.
2 over 3 pi. Okay, yeah, the change between the base there. So it's 2 over 3 pi multiply. So what is the height of the rectangular? It's 25. Do you see it? Because you are here on this rectangular, the height is 25. On the small rectangular, what do we have? What is the base? 360 minus 220.
7 over 9 pi.
7 over 9 pi multiplied by 5, right?
Yeah.
Yeah, like I said, if someone else wants, he can come and start with the long rectangular like this. And this way, you're still gonna get the same answer. Do you see what I mean?
Please repeat.
You can also cut, let me use the different colors. You can also cut the rectangulars like this. You can call this one 1, you can call this one 2, you can call you're still gonna get the same thing.
Okay.
Yes, but for consistency, let's use what we are using. So what is W? We keep it in terms of pies.
Uh, 2 to 1.
2 to 1.
Comma 657.
Can you give me a pie?
Okay.
So
It's 70.
70.
And then 5 over 9 pi.
It is 70 like this.
Yeah.
Divided by 5.
No, like 70 and 5 over pi over 9.
I don't understand. 70
5 over 9 pi.
like this.
No. It's 7 over 9, 5 pi.
7 over
7 over 9.
70
pi.
over 9 pi. Okay. Not 5. So I put 9 here.
Yeah.
And then pi here.
Yeah.
Joule. Okay, what do we do from here? We go with what? Min torque to be equal to 70 over 9 pi divided by what? By 2 pi. This will cancel this. So what will be the answer of the min torque?
Okay.
Is that?
35.
It is 35.
Yeah, 35,278.
As we got 21 in class, can we check where we are going wrong? I'm sure it has to be 21. That's what we got in class when we did this for the min torque.
Okay.
Let's check first the area. The base 5/9 over pi multiplied by 40 plus 2 over 3 multiplied by 25 plus 7. Okay, can we check the area? What are we getting? because we got 21 in class. And I believe that 21 is the right answer.
Yeah, it's 21, so. Yeah.
What was the problem, Andy?
It was the area.
Or the areas? What was the area? What's the right area?
It was 42 over 97 pi.
It is 42?
42 over 97 pi.
Over 9, 7 pi.
Yeah.
I don't know how to write it. You mean 42 like this, over 9,
Yeah.
and then 7 pi.
Yeah.
That was the area.
Yes.
So if you divide this area here by 2 pi, what do we get? We get 21.
Yeah.
21 comma?
21,39.
Okay, 39. That's the mean torque in Newton meter. So if I can, I just want to scratch this one to show that this one is wrong and this is the right one. So are we good, Andele, from here? So what do we do
Yes.
from here? You come here, you represent what, Andele? You represent your mean torque. 21, do you agree it is just below 25, right? So it has to be somewhere here. So do you agree on this one? I can write
Yes.
this one to be 21,39. So this is the mean torque. So when we plot something like this, what is the EF? It is what? It is area above the mean torque. That area will include only these ones here. Are we together on that one?
Yes.
The EF is the area above the mean torque.
Yes.
Now, Andile, we will get back to it. What was the question asked? The question asked was to solve for the torque. Now, if we find the mean torque, what do we know about the machine? We know that T mean multiplied by W machine is equal to T motor multiplied by W motor. So what is T mean? You know that T mean is 21,39. Right? What is W of the motor? W of the motor, okay, it is not given, but if you read here, what did they say? They said the machine is driven through gearing by an electric motor whose speed is 4 times than the one of the machine. They say the speed of the motor is 4 times the speed of the machine. Do you see it?
From izolo lapha sorry.
No, it's fine, it's fine. No.
Yeah, you can continue.
Okay, when they say the machine is driven through gearing by an electric motor whose speed is 4 times that of the machine. So speed of the motor is 4 times the one of the machine. So what does it mean? Here, I will write what? W machine, right? When it comes to the motor, I'm going to write torque of what? Of the motor. But when it comes to speed of the motor, I will write 4 times W of the machine. Is it making sense? Or should I repeat? Andile? Andile? Hello? Andile. Hello. Let me check if she's still here, bro. Oh. She seems like she got network issue, bro.